I'm Peter Carr, and today we're going to look at doing the setup for a serpentine brick wall, or sometimes called a Crankle wall. In particular, marking out the wall and then setting up the first course.
The first thing we're going to do to mark out the serpentine wall will be a line that is central to the curves either side of that central line. That line is flicked with a chalk line. You then need to find a striking point that will be equal distances from both sides of that central line. The striking point may be determined by a plan, or if you have the liberty of designing your own serpentine wall, then you can choose whatever striking point suits you. It will be dependent upon the space that you have and also the size curve you want for the serpentine wall. Once that line's been marked on one side, then another line will be marked on the other side of the central line, again for the purposes of creating striking points from which the radius will be marked. It is then a matter of using a type of trammel to set out and mark the curve. For this particular exercise, we'll be using a straight edge and pencil, or a straight edge and marker, to mark that curve. These are the second two lines that are being flicked, from which the striking points will be taken. To keep the one end of the trammel steady, it's probably simplest to drill a hole through the straight edge or timber, or even use a string line, but just remember that string lines are stretch and may not give an accurate curve. But once that hole is drilled through, then something such as a peg, a line pin, can be held into the ground, the surface below, to keep it in the same position. Once the first curve crosses the central line, that line can be extended to the other side of the curve, and a radius of the same distance marked out and measured. Now, in order to make or simplify the construction of the serpentine wall, sometimes templates, curved templates, are marked and cut out to be held against the brickwork and used to maintain the same curvature as the wall is constructed. Once the line has been drawn on the ground, materials such as bracing ply could be placed down the ground, and then the line redrawn over the top of the bracing ply. That bracing ply can then be cut to the shape required. The important part to remember is that when the bricks are laid to the line drawn, they'll be laid on the outside of one side of the serpentine wall. For example, this side, they'll be laid on the near side. As the bricks are laid a lot further along the serpentine wall, when it curves away from us, the bricks will be, in a sense, inside the line. The effect of this is that the curvature on this side, or the left end of the serpentine wall, will be slightly different from the curvature of the template on the right side or the other end of the serpentine wall. The difference is being 110 mm in the radius, that is the width of the brick. Therefore, if a template is to be held on the inside curve of the wall, it will be 110 mil, the radius that is, will be 110 mil shorter on one side or one end of the serpentine wall than the other. The benefit of setting up a template that can be held against the bricks is that more time can be spent on plumbing striking points along the brick wall and leveling, rather than plumbing every single brick along the length of the serpentine wall. Here we're marking out the second template, which is, as I mentioned earlier, designed so that it's 110 mil away from the line drawn on the floor. Here the line's being redrawn onto the template material. You can just see that the radius has been reduced by that 110 millimeters. It's important then to mark the template correctly so that this particular curvature will not be used on the other end of the serpentine wall, but in fact on this end, the end nearest to the laser level. And as with most brick jobs, it's best to set out the wall dry bond or trace out the bond dry to make sure that the perp ends are neat and that the bond works in the middle section of the wall. On this particular wall, we're going to stabilize the ends of the wall and the middle section of the wall with an additional attached pier. The pier can be bonded into the brickwork and as such would be called an engaged pier, but in this occasion we'll lay an attached pier with the use of cavity ties. Here I'm marking plumb points along the wall. Plumb points can be set out at approximately 1000 millimeters to 1200 millimeters apart, that being the approximate length of a level. 5 bricks can then be laid at a time with a level, but each of those 5 bricks apart are plumbed. In between the plumb points, the template can be used, held against the brickwork to check for the face alignment. Just because the template's being used doesn't automatically mean that the wall will be plumb all along the wall, and therefore every 3 to 4 courses certainly the spirit level should be used to check that. Now, on top of the plumbing issue, we must make sure that when the bricks are set out, that the first course, the entire length of the course, is level. It could be done using a water level or automatic level. Here we've chosen to use a laser level because it's a one-person operator. I set out the height for the first brick laid, obviously finding the highest point and using the highest point of the concrete to lay the first brick, and then bedding the other bricks up along the length of the wall. A brick on each end of the wall is laid, and now we're looking at laying each brick that's set out along the plumb point. The first plumb point being, as I mentioned earlier, approximately 5 bricks away from the end of the wall, and then the next would be again another 5 bricks away, as can be seen. Each of these bricks can be levelled off the other, and then the other bricks laid in between, and the cut curve template held firmly against those bricks laid in between, checking that the curvature remains the same and consistent throughout the construction of the wall.